Hello everyone. So in this lecture we'll see the stresses in the bars of different sections. So we'll see first the derivative formula, then we'll see the problems related to it. Okay. So stresses in the bars of different sections. So sometimes a bar is made up of different lengths having different cross-sectional areas as shown in figure. So in such cases, the stresses and strains and hence changes in length for each section is worked out separately as usual. The total changes in length is equal to the sum of the changes of all individual lengths. It may be noted that each section is subjected to the same external axial pull or push. So here this is the bar which is having different cross section. Here is different cross section, here is different cross section, and here is different cross section. Okay. So let P is equal to force acting on the body, capital E is equal to modulus of elasticity for the body, L1 is equal to length of section 1, A1 is equal to cross sectional area of section 1, then L2 is L2 A2 corresponding values for section 2, and so on. So we know that the change in length of section 1, delta L1 is equal to PL1 upon A1E. Similarly, delta L2 is equal to PL2 upon A2E, and so on. Total deformation of the bar delta L is equal to delta L1 plus delta L2 plus delta L3 is equal to, so delta L1, so we all know that the formula for deformation, that is delta L. So here is equal to PL1 upon A1E plus PL2 upon A2E plus PL3 upon A3E plus dash 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 is equal to P upon E common, then in bracket L1 upon A1 plus L2 upon A2 plus L3 upon A3 plus so on. So note, sometimes the modulus of elasticity is different for different section. In such cases, the total deformation is equal to. So now we'll also have the different values for E1, E2, E3. Okay. So delta L is E1 plus L2 upon A2, E2 plus L3 upon E3, E3 plus so on. So now we'll see the problems related to this. An automobile component shown in figure is subjected to a tensile load of 160 kilonewton. Determine the total elongation of the component if its modulus of elasticity is 200 GP. So this is the component having different area, size, load. Sorry, load is same. Then having different lengths. So we'll see the bar. So given data here, given tensile load, that is P is equal to 160 kilonewton, 160 into 10 raised to 3 newton. Length of section, that is L1 is equal to 90 mm. Length of section 2, L2 120 mm. Area of section, that is A1 that is 50 mm square. Area of section 2, that is A2 is equal to 100 mm square, and modulus of elasticity E, capital E, is equal to 200 GPa is equal to 200 into 10 raised to 3 Newton per mm square. We know that total elongation of the component delta L is equal to P upon E into bracket L1 upon A1 plus L2 upon A2 is equal to 160 into 10 raised to 3 upon 200 into 10 raised to 3 in bracket 90 upon 50 plus 120 upon 100 is equal to 0.8 into 1.8 plus 1.2 is equal to 2.4 mm. So this is the value of delta L for this component. Next section or next problem, a member formed by connecting a steel bar to an aluminum bar is shown in figure. Steel bar 50 by 50. So here, assuming that the bars are prevented from buckling sidewise, calculate the magnitude of force P that will cause the total length of the member to decrease by 0.25 mm. The values of elastic modulus for steel and aluminum are 210 GPa and 70 GPa respectively. So this is the component, or this is the bar from different lengths and different areas. Okay, so we have to find here magnitude of the force. So given data, given decrease in length, that is delta L is equal to 0.25 mm. Modulus of elasticity for steel, that is ES 210 GPa is equal to 210 into 10 raised to 3 Newton per mm square. Then modulus of elasticity for aluminum, EA is equal to 70 GPa is equal to 70 into 10 raised to 3 Newton per mm square. Area of steel section A3 sorry, AS is equal to 50 by 50 is equal to 2500 mm square. Area of aluminium section A is equal to 100 by 100 mm is equal to 10,000 mm square. Then length of steel section is equal to LS is equal to 300 mm, and length of aluminium section that is LA is equal to 380 mm. So now P is equal to magnitude of the force in kilonewton. We know that the decrease in the length of the member is delta L is equal to 0.25. Then the formula for the deformation is equal to P into bracket LS upon AS ES plus LA upon AA into EA. So by substituting the values is equal to P is equal to P into bracket 300 upon 2500 into 210 into 10 raised to 3 plus 380 upon 10,000 into 70 into 10 raised to 3 is equal to 780p upon 700 into 10 raised to 6. 10 raised to 6. So is equal to P is equal to 0.25 into 700 into 10 raised to 6 upon 780 is equal to 224.4 into 10 raised to 3 Newton is equal to 224.4 kilonewton. This is the magnitude of the force. Thank you.